Look up in New York, Chicago, Shanghai, Dubai, Hong Kong, Houston. Cities across the world reach into the sky, glass towers, steel giants. Buildings containing thousands of people. Entire communities stacked vertically. Modern civilization has become accustomed to height. We admire skylines, photograph skyscrapers, work in towers, live in high-rise apartments, and rarely ask a simple question: how did humanity get up there? For most of history, height was a problem. The higher a building rose, the harder it became to use. Stairs imposed limits. Human endurance imposed limits. Architecture imposed limits. A city could grow outward, but growing upward was far more difficult. Then one invention changed everything. A machine so common that most people barely notice it. A machine hidden inside walls and shafts. A machine used billions of times every day. The elevator. Not a weapon, not a vehicle, not a computer. Yet one of the most transformative inventions ever created. Because without the elevator, there would be no skyline. This is the story of the elevator, the invention that built the skyline. Act 1. The problem of height. For thousands of years, humans built upward only reluctantly. Height created challenges. Materials had limits. Engineering had limits. Most importantly, people had limits. Climbing stairs consumes time, consumes energy, consumes effort. The higher a building became, the less desirable its upper floors often became. Today, penthouses occupy the top of buildings. For most of history, the opposite was true. The wealthy preferred lower floors. The poor often occupied the highest because they had to climb every day, every trip, every errand, every return home. Height carried a penalty, and that penalty shaped architecture for centuries. Act 2. Ancient attempts. The desire to lift heavy objects is ancient. Builders of temples, fortresses, monuments, all confronted the challenge. How do you raise weight against gravity? Simple lifting devices appeared thousands of years ago. Ropes, pulleys, counterweights, human labor, animal power. Ancient engineers developed remarkable solutions. Some historians believe primitive lifting platforms existed in the Roman world. Others appeared in mines and construction projects throughout history. Yet, these devices were not elevators in the modern sense. They moved materials, not large numbers of people. The dream of vertical transportation remained incomplete. Act 3. The tyranny of stairs. Imagine a 6-story building in the 18th century. Today that might seem modest, but before elevators, 6 stories could feel enormous. Every trip required climbing. Workers climbed. Residents climbed. Visitors climbed. Deliveries climbed. Everything depended upon stairs. The consequences shaped urban life. Buildings rarely grew very tall. When they did, upper floors often lost value. The economics of height worked against vertical expansion. Gravity governed architecture, and gravity seemed unbeatable. Act 4. The Industrial Revolution. The 19th century changed everything. Factories expanded. Cities grew. Populations increased. Technology accelerated. Steam engines transformed industry. Railroads transformed transportation. New engineering ideas emerged. Inventors searched for ways to solve old problems, including the problem of vertical movement. If machines could move freight across continents, perhaps they could move people upward. The idea seemed increasingly possible, but one obstacle remained, a terrifying obstacle. Act 5. The fear of falling. Early lifting platforms existed. Factories used them. Warehouses used them. Industrial operations used them. Yet most people did not trust them. For good reason. If a rope failed, disaster followed. A falling platform could be deadly. The risk limited adoption. No matter how useful vertical transportation appeared, people would not willingly ride machines they believed could kill them. The challenge was not simply engineering, the challenge was trust. Until someone solved the safety problem, the elevator would remain limited, and the skyline would remain low. Act 6. A world growing taller. Meanwhile, cities continued expanding. Population growth accelerated. Land became more valuable, particularly in urban centers. As cities became denser, building upward became increasingly attractive. A taller building could accommodate more people, more offices, more businesses, more residents. Developers recognized the opportunity. Architects imagined possibilities. Engineers explored solutions. Everyone sensed that height represented the future. They simply lacked the technology needed to unlock it. Act 7. The Inventor. In the middle of the 19th century, an American inventor began working on a solution. His name was Elisha Otis. At first glance, his work appeared modest. He was not designing skyscrapers. He was not redesigning cities. He was solving a practical engineering problem. How do you prevent a lifting platform from falling if a cable breaks? The question seemed technical, narrow, specific, but history often turns on specific questions. And the answer Elisha Otis developed would change the future of architecture. Act 8. The moment everything changed. In 1854, at an exhibition in New York City, Elisha Otis staged a demonstration. He stood on a platform suspended above a crowd. The platform was held by a rope. Then the rope was cut. Observers expected disaster. Instead, the platform stopped. Otis's safety mechanism worked. The crowd witnessed something extraordinary. Not merely a machine, but a solution. A solution to fear. A solution to risk. A solution to the problem that had limited vertical transportation for generations. The demonstration lasted only moments. Its consequences would last centuries. The age of the elevator had begun. Act 9. The invention becomes an industry. Elisha Otis had solved the problem, or at least the most important part of it. People could now trust a lifting platform. Trust changed everything. Throughout history, countless inventions failed not because they lacked usefulness, but because they lacked confidence. The elevator was different. Once safety could be demonstrated, possibilities multiplied. Factories adopted lifting systems. Warehouses expanded their use. Businesses began imagining new applications. What if elevators moved more than cargo? What if they moved people? The question seemed simple. Its consequences would be revolutionary. Act 10. The First Passengers. In 1857, a milestone arrived. The first commercial passenger elevator was installed in New York City. The building was not particularly tall by modern standards. Only a few stories, yet something remarkable had happened. People were now paying to ride vertically. The journey lasted only moments. The distance was modest, but the principle was profound. For thousands of years, stairs had been unavoidable. Now an alternative existed. Passengers entered a machine, pressed upward, and emerged on another floor without climbing. The experience felt modern, even futuristic, a glimpse of a different urban future. Act 11. New York looks up. Few places were better positioned to appreciate elevators than New York. The city was growing rapidly. Land was valuable. Commerce was expanding. Population density increased year after year. Every square foot mattered. Developers faced a challenge. How could they create more space when land was limited? The answer increasingly pointed upward. Elevators did not create the desire to build taller structures. That desire already existed. Elevators made it practical. A tall building could now function efficiently. Workers could reach offices. Customers could reach businesses. Residents could reach homes. Height was becoming useful, and usefulness creates demand. Act 12. The reversal of value. One of the most surprising consequences of the elevator involved real estate. For centuries, upper floors had often been less desirable. More stairs, more effort, more inconvenience. The lower floors commanded higher value. The elevator reversed that relationship. Suddenly, upper floors offered advantages, better views, cleaner air, more sunlight, less street noise. The top of a building transformed from burden to luxury, a pattern that continues today. Penthouse apartments, executive offices, observation decks, all owe their existence to vertical transportation. The elevator changed not only buildings, it changed economics. Act 13. The birth of an industry. Demand created opportunity. As elevators became more common, manufacturers expanded, engineers improved designs. Companies specialized in vertical transportation. Competition encouraged innovation. Systems became safer, more reliable, more efficient. Entire businesses emerged around installation and maintenance. The elevator industry began taking shape. At first, it served a relatively small market, but that market would not remain small for long, because another technological revolution was approaching, one that would transform elevators forever. Act 14. From steam to hydraulics. Early elevators often relied on steam power. The technology worked, but it possessed limitations. Engineers searched for alternatives. Hydraulic systems offered one possibility. Using pressurized fluid, hydraulic elevators could lift significant weight. The approach improved performance, expanded capabilities, encouraged further adoption. Buildings gained new options. Architects gained new confidence. Developers gained new opportunities. The technology continued evolving. Each improvement made taller buildings more practical. Each improvement pushed cities a little higher. Act 15. The Electric Revolution. Then came electricity, one of the most transformative technologies in human history. Electric power changed factories, changed homes, changed communication, and changed elevators. Electric motors offered major advantages: greater efficiency, improved control, increased reliability, faster operation. The impact was dramatic. Elevators became more capable, more attractive, more practical. The machine that had begun as a lifting platform was becoming a sophisticated transportation system, and cities were ready for it. Act 16. The building boom. The late 19th century witnessed extraordinary urban growth. Factories expanded, businesses multiplied, office work increased. Cities became centers of economic activity. The demand for space surged. Architects searched for ways to accommodate growth. Developers sought ways to maximize valuable land. Elevators offered a solution. Not the only solution, but an increasingly important one. Every improvement in vertical transportation expanded what buildings could become. Height no longer represented merely an engineering challenge. It represented opportunity. Act 17. A new kind of city. For most of history, cities spread horizontally. Neighborhood after neighborhood. Street after street. Expansion moved outward. The elevator introduced another possibility. Vertical growth. A city could now stack activity. Multiple businesses, multiple offices, multiple homes, all occupying the same footprint. The implications were enormous. Land could be used more efficiently. Density could increase. Urban centers could support larger populations. The shape of cities began changing. Slowly at first, then rapidly. The skyline was still young, but its future was becoming visible. Act 18. The machine inside the wall. Most great inventions announce themselves. Railroads thunder across landscapes. Automobiles fill streets. Airplanes dominate the sky. The elevator took a different path. It hid inside buildings, behind doors, within shafts, out of sight. Its influence was immense. Its visibility was limited. People admired buildings, rarely the elevators inside them. Yet those buildings increasingly depended upon vertical transportation. The elevator was becoming the invisible engine of urban growth, a machine hidden in plain sight, and soon it would help create one of the defining symbols of the modern world, the skyscraper. Act 19. The perfect partnership. Some inventions succeed alone. Others change the world only when combined with another innovation. The elevator belonged to the second category. By itself, it solved the problem of vertical transportation. But another challenge remained. How do you build a structure tall enough to justify an elevator? For centuries, buildings relied on load-bearing walls. The higher a building rose, the thicker its lower walls needed to become. At sufficient height, the walls became impractical, heavy, expensive, space-consuming. Architecture faced a physical limit. Then came steel, and everything changed. Act 20. The steel frame. Steel possessed remarkable properties. Strong, durable, relatively lightweight, capable of supporting enormous loads. Engineers realized that a building no longer needed thick masonry walls to support itself. Instead, a skeleton of steel could carry the weight. The walls could simply enclose the structure. This idea was revolutionary. A steel frame could rise far higher than traditional construction methods allowed. Suddenly, architects possessed a new tool. Developers possessed new opportunities. Cities possessed a new future. But a tall building remained useless if people could not comfortably reach the upper floors. That is where the elevator entered the story. The skyscraper would be born from the marriage of steel and vertical transportation. Act 21. Chicago's experiment. In the late 19th century, Chicago became a laboratory of modern architecture. The city had suffered the devastating Great Chicago Fire of 1871. Large portions needed rebuilding. Growth remained rapid. Economic activity expanded. Architects and engineers embraced innovation. Among them were pioneers willing to challenge traditional assumptions about height. They experimented with steel frame construction, new building designs, new structural systems. The result was something unprecedented. Structures rising higher than previous generations believed practical. The first skyscrapers. Act 22, the Home Insurance Building. In 1885, Chicago unveiled what many historians consider the world's first skyscraper, the Home Insurance Building. By modern standards, it was modest, only 10 stories initially, later expanded to 12. Today, such a building might seem ordinary. At the time, it was extraordinary. Its steel frame represented a new direction in architecture. Its height suggested future possibilities, and its elevators made the height usable. The building demonstrated a powerful truth. Cities no longer needed to spread outward alone. They could rise upward. A new era had begun. Act 23, the race to the sky. Once a possibility becomes reality, competition often follows. Developers wanted taller buildings. Architects wanted greater achievements. Businesses wanted prestige. Cities wanted recognition. Height became a symbol, a measure of ambition, a declaration of confidence. The race upward accelerated. One building surpassed another. Then another surpassed that. Each new structure pushed boundaries. Each required reliable elevators. The higher buildings climbed, the more essential vertical transportation became. Without elevators, the race would have ended quickly. With elevators, it seemed almost limitless. Act 24. The modern office. The skyscraper created new opportunities for business. Companies could occupy multiple floors. Thousands of workers could operate within a single structure. Office towers emerged as engines of commerce. Elevators made them practical. Imagine a 20-story office building without elevators. Every employee climbing stairs daily. Every visitor struggling upward. Every delivery carried manually. The inefficiency would be overwhelming. The elevator transformed office life, making vertical business possible, making dense urban economies possible, making the modern corporate world possible. Act 25. The changing skyline. As skyscrapers multiplied, city skylines transformed. For centuries, church steeples and government buildings often dominated urban horizons. Now commercial towers joined them, then surpassed them. Steel and elevators allowed private enterprise to shape the skyline. Cities became visual expressions of economic power. The horizon itself changed. Visitors arriving in major cities encountered something new. A forest of towers. A landscape created not by nature, but by engineering. And hidden within every tower was an elevator. Act 26. The human experience of height. The elevator changed more than architecture. It changed perception. For most of history, height was unusual, reserved for towers, mountains, special places. Now ordinary people could ascend dozens of stories with ease. A worker could reach the 20th floor in moments. A visitor could view an entire city from above. A resident could live high above the streets. The experience of height became democratized, accessible, routine, normal. The elevator transformed altitude from privilege into everyday reality. Act 27. New York enters the competition. Chicago may have pioneered the skyscraper, but New York would perfect it. The city's geography encouraged vertical growth. Manhattan possessed limited land. Demand remained enormous. Property values soared. Developers searched for ways to maximize every parcel. The answer increasingly pointed skyward. Taller buildings generated more rentable space, more offices, more tenants, more revenue. The economic logic was irresistible, and elevators made it possible. New York embraced the vertical future with extraordinary enthusiasm. Act 28, the City of the Future. By the dawn of the 20th century, something remarkable had happened. A new type of city had emerged. A city organized around vertical movement. A city filled with elevators, office towers, hotels, apartment buildings, commercial structures. The skyline itself became a symbol of modernity, a declaration that technology had conquered old limitations. Gravity still existed, but humanity had learned to negotiate with it. The elevator played a central role in that achievement. The machine hidden inside buildings had become one of the defining technologies of urban civilization. Yet the tallest towers were still ahead. The greatest race upward had not even begun. Act 29, the capital of height. By the early 20th century, New York City had become the center of a new architectural age. The city was crowded, prosperous, ambitious. Every year, demand for space increased. Every year, land became more valuable. And every year, buildings climbed higher. The skyline was no longer merely a collection of structures. It was becoming a competition, a contest of engineering, a contest of prestige, a contest of vision. Developers wanted attention. Businesses wanted visibility. Architects wanted immortality. The result was a race toward the clouds. And elevators made every foot of that journey possible. Act 30, the Woolworth Building. In 1913, a new tower appeared in Lower Manhattan, the Woolworth Building. Rising more than 700 feet into the sky, it was among the tallest buildings on Earth. To many observers, it seemed almost impossible. A structure so tall that it dominated the skyline. A building often called the Cathedral of Commerce. Yet for all its beauty and grandeur, it depended upon something surprisingly ordinary: elevators. Without them, the upper floors would have been difficult to rent, difficult to access, difficult to use. The tower's success relied upon vertical transportation. The elevator transformed height into value, and value drove construction ever higher. Act 31. The building as a machine. As skyscrapers expanded, architects began thinking differently. A tall building was no longer simply a structure. It became a system, a complex machine designed to support thousands of people. Electricity, heating, ventilation, water, communications, and elevators all had to work together. The elevator became one of the most important components. A skyscraper without reliable elevators was like a railroad without locomotives. The structure might exist, but it could not fulfill its purpose. Vertical transportation became the beating heart of the modern tower. Act 32. The elevator operator. For much of the early 20th century, elevators required human operators. Passengers entered. An operator controlled movement, opened doors, closed doors, managed stops. the profession became a familiar part of urban life. Hotels employed operators. Office buildings employed operators. Apartment towers employed operators. Millions of people encountered them every day. The elevator operator became a symbol of modern city living, a guide through the vertical world, a human bridge between floors. Today, most elevators operate automatically, but for generations, operators represented the face of vertical transportation. Act 33. The Chrysler Building. The 1920s brought a new wave of ambition. Among the most celebrated results was the Chrysler Building, completed in 1930. Its gleaming crown transformed the New York skyline. For a brief moment, it became the tallest building in the world. The tower represented engineering confidence, architectural creativity, corporate prestige. Yet, like every great skyscraper, it depended upon elevators. Passengers needed to move efficiently through dozens of floors. Workers needed access to offices. Visitors needed access to observation areas. The elevator transformed a monumental structure into a usable one. Act 34. The Empire State Building. Then came the Empire State Building, completed in 1931. 1,250 feet tall, a structure so ambitious that it seemed to belong to the future. For decades, it remained the tallest building in the world. Its construction captured global attention. Its silhouette became iconic. Its observation decks attracted visitors from around the globe. Yet, hidden within its steel frame existed one of the most sophisticated elevator systems ever created. Without those elevators, the tower's extraordinary height would have been largely impractical. The Empire State Building demonstrated the ultimate power of vertical transportation. It showed what cities could become. Act 35. The Economics of the Sky. The elevator transformed more than architecture. It transformed economics. Every additional floor represented opportunity. Additional offices, additional apartments, additional revenue. Land in major cities remained finite. Height created more usable space without requiring more land. The financial implications were enormous. Developers embraced vertical growth. Investors funded ambitious projects. Businesses concentrated in dense urban centers. The elevator became an economic engine, quietly generating value floor after floor, year after year. Act 36. The Rise of the Grand Hotel. Hotels also benefited from elevators. Large urban hotels welcomed thousands of guests. Many occupied substantial towers. Elevators allowed visitors to access rooms efficiently. Luxury moved upward. Upper floors offered better views, more privacy, more prestige. The experience of travel changed. A guest could stay dozens of stories above the street, an idea that would have seemed remarkable only decades earlier. The elevator made vertical hospitality possible. Act 37. The Vertical Home. Apartment living changed as well. Before elevators, upper-floor apartments often carried disadvantages. After elevators, they offered advantages: views, light, distance from noise. Developers responded accordingly. Luxury apartments rose higher. Residential towers expanded. Urban living acquired a new dimension. The city became a place not merely of streets and neighborhoods, but of floors, levels, and vertical communities. Act 38. A New Way of Life. By the 1930s, elevators had become woven into everyday urban existence. Workers used them. Residents used them. Visitors used them. Tourists used them. Millions of journeys occurred daily. Most lasted less than a minute. Yet collectively they transformed civilization. The elevator altered how cities grew, how businesses operated, how people lived, how architecture evolved. And the transformation was only beginning. Because soon elevators would face new challenges: war, population growth, suburban expansion, and eventually the rise of a truly global skyline. Act 39. War and Pause. In the early 20th century, the race toward the sky seemed unstoppable. Skyscrapers grew taller, cities grew denser, elevator technology advanced steadily. Then the world changed. The Second World War redirected resources. Steel went to shipyards. Factories shifted to military production. Engineers focused on wartime needs. Across much of the world, ambitious construction projects slowed or stopped. The skyline paused, but only temporarily. The forces that had created the vertical city remained: population growth, economic expansion, urban concentration, the need for space. When peace returned, those forces would re-emerge with extraordinary power, and elevators would once again help shape the future. Act 40. The post-war boom. The decades after World War I witnessed one of the greatest economic expansions in modern history. Industries grew, corporations expanded, cities evolved. New technologies entered daily life. The modern office became increasingly important. Large organizations required large amounts of space. Thousands of employees worked within single buildings. The scale was unprecedented. Managing such environments required efficient vertical transportation. Workers had to reach offices quickly. Visitors had to move easily. Deliveries had to be coordinated. The elevator was no longer a luxury. It was infrastructure, as essential to the office tower as electricity or plumbing. Act 41. The automatic elevator. For decades, elevator operators had guided passengers from floor to floor, but technology continued advancing. Automatic controls improved. Reliability increased. Safety systems became more sophisticated. Gradually, elevators no longer required operators. Passengers pressed buttons. The system handled the rest. At first, some people felt uncertain. Would the machines be reliable? Would they be safe? The same questions had been asked about elevators themselves a century earlier. As confidence grew, automatic elevators became standard. A familiar profession faded. A new era began. Act 42, the age of the office tower. By the 1950s and 1960s, office towers became symbols of corporate power. Banks built towers. Insurance companies built towers. Manufacturers built towers. Corporate headquarters rose above city streets. Glass and steel architecture flourished. The skyscraper became a statement, a visible expression of economic success. Yet every tower depended upon the same hidden system: elevators. Thousands of workers might enter a building each morning. Without efficient vertical transportation, chaos would follow. The elevator made modern office culture possible. Act 43, the morning rush. Every major city developed a familiar ritual. Morning, workers arriving, elevator doors opening and closing, crowds moving upward, a process repeated every weekday. millions of times. The scale was extraordinary. Entire buildings depended upon moving people quickly and efficiently. Engineers studied traffic patterns, peak demand, passenger behavior. Elevator design became increasingly scientific. The challenge was no longer merely lifting people. The challenge was managing movement, managing time, managing flow. The elevator had evolved into a sophisticated transportation network operating inside buildings. Act 44, the suburban paradox. After the war, millions of Americans moved to suburbs. Single-family homes expanded across the landscape. Automobiles reshaped daily life. At first glance, suburbanization appeared to reduce the importance of elevators. Yet the opposite often occurred. As metropolitan regions expanded, urban centers continued serving as hubs of finance, government, and commerce. Downtown office towers remained essential. Hospitals expanded vertically. Hotels expanded vertically. Apartment buildings expanded vertically. The skyline continued growing even as suburbs spread outward. America was developing in two directions simultaneously, horizontally and vertically, and elevators remained vital to one of those dimensions. Act 45, the global spread of the skyscraper. For decades, the skyscraper had been closely associated with American cities, especially New York and Chicago. After World War, that began to change. Around the world, nations embraced modern architecture. Office towers appeared in Europe, Asia, Latin America, the Middle East. Urban populations expanded. Economic growth accelerated. Cities searched for efficient ways to accommodate millions of people. The elevator traveled with the skyscraper. Every new tower required it. The invention that helped shape American cities was becoming a global technology. Act 46, the science of speed. As buildings grew taller, speed became increasingly important. A short ride in a 10-story building is one thing. A ride in a 50-story building is another. Engineers improved motors, control systems, braking systems, ride quality. Passengers expected comfort, efficiency, reliability. The elevator became faster, smoother, more sophisticated. What once seemed miraculous gradually became routine. A journey that would have exhausted a person climbing stairs could now be completed in seconds. Act 47, the hospital vertical. Some buildings depend upon elevators more than others. Hospitals are among them. Patients, doctors, equipment, supplies, emergency teams, all require movement. Every minute matters. Elevators became essential components of modern healthcare facilities. Their reliability could influence outcomes. Their efficiency could save time. Their presence shaped hospital design. Once again, the elevator proved that its influence extended far beyond convenience. It affected how institutions functioned, how services were delivered, how lives were supported. Act 48, the hidden system. The most successful technologies often disappear into everyday life. Electricity, running water, telecommunications. People notice them primarily when they fail. The elevator joined that category. Passengers entered, pressed a button, expected movement, expected safety, expected reliability, and usually received all three. Its extraordinary success made it almost invisible. Yet behind every successful journey stood generations of engineering, innovation, maintenance, and design. The elevator had become one of civilization's most trusted machines. And as cities continued rising, that trust would become even more important, because the tallest towers in human history were still waiting to be built. Act 49. The Age of the Megatower. By the second half of the 20th century, the skyscraper had become a familiar part of urban life. Yet architects and engineers were not satisfied. The race upward continued. New technologies, new materials, new ambitions, all pointed toward greater height. Buildings were no longer measured merely in stories. They were measured in hundreds of feet, then thousands. The challenge was no longer simply constructing tall structures. The challenge was moving people through them. A 100-story building without efficient elevators would be little more than a monument. To function, it required transportation. Not roads, not railways, vertical transportation. Act 50. The World Trade Center. In the early 1970s, New York unveiled one of the most ambitious construction projects in history, the World Trade Center. Twin towers rising above the skyline, each containing more than 100 stories, each housing thousands of workers. The scale was unprecedented. The engineering was extraordinary. Yet among the most remarkable features were the elevators. Traditional elevator designs faced limitations. If every elevator traveled from the ground floor to every destination, too much space would be consumed. Engineers developed new approaches: sky lobbies, express elevators, transfer systems. The building functioned almost like a vertical subway network, a transportation system operating inside a structure. The future of skyscrapers would increasingly depend upon such innovations. Act 51. The building as a city. As towers grew larger, they began resembling cities. Workers arrived in the morning. Restaurants served meals. Shops operated. Maintenance crews worked continuously. Thousands of people occupied the same structure. The elevator became the primary means of movement. Just as roads connect neighborhoods, elevators connected floors. Just as rail systems connect districts, elevator networks connected vertical zones. The modern skyscraper evolved into a city turned upright, and elevators became its transportation infrastructure. Act 52. The computer takes control. For decades, elevator systems relied primarily upon mechanical controls. Effective, reliable, but limited. Then computers arrived. Microprocessors transformed elevator management. Systems could analyze demand, coordinate movement, reduce waiting times, improve efficiency. A bank of elevators could operate as a unified network, rather than as individual machines. The improvement was profound. Passengers spent less time waiting. Buildings functioned more smoothly. Traffic flowed more efficiently. The elevator entered the digital age. Act 53. The Science of Flow. Moving thousands of people through a tower is not a simple task. It is a logistical challenge. Engineers study patterns, arrival times, departure times, lunch periods, peak demand. Every minute matters. An inefficient elevator system can reduce productivity, create frustration, limit the usefulness of a building. The science became increasingly sophisticated. Algorithms replaced guesswork. Data-informed design. The elevator was no longer merely a machine. It was becoming an intelligent system. Act 54. The rise of Asia. As the 20th century approached its end, a major shift occurred. The center of skyscraper construction began moving eastward. Cities across Asia expanded rapidly. Economic growth accelerated. Urban populations surged. New skylines appeared. Hong Kong, Singapore, Shanghai, Seoul, Taipei, and many others, each embraced vertical development. Each required elevators. The invention born in the 19th century became essential to 21st century urbanization. Its influence spread across continents, across cultures, across languages, because the challenge of height is universal, and so is the solution. Act 55, faster than ever. The world's tallest buildings required new capabilities. Passengers could not spend excessive time traveling between floors. Speed became critical. Manufacturers competed to create faster systems. Engineering limits were pushed, ride quality improved. Acceleration became smoother. Travel times decreased. Some elevators reached astonishing speeds, transporting passengers hundreds of feet in seconds. The experience remained almost magical. Step inside. Press a button. Arrive dozens of floors higher before fully realizing the journey has begun. Act 56. The problem of the super tall. As buildings exceeded 50 stories, then 70, then 100, new challenges emerged. Elevator shafts consume space. More elevators require more room. More room reduces rentable area. Architects faced difficult trade-offs. How can a building become taller without sacrificing efficiency? The answer required innovation. Double-deck elevators, express systems, advanced scheduling, sophisticated computer controls. Again and again, elevator technology expanded the limits of architecture. Each breakthrough allowed buildings to rise higher. Act 57. The view from above. One of the elevator's greatest gifts is perspective. For most of human history, only a small number of people experienced great heights. Today, millions do. Office workers gaze across cityscapes. Residents watch sunsets from upper floors. Tourists visit observation decks. The experience shapes perception. A city seen from above feels different, larger, more interconnected, more alive. The elevator transformed these experiences from rarity into routine. It democratized the skyline, making extraordinary views available to ordinary people. Act 58. The skyline goes global. By the beginning of the 21st century, skyscrapers could be found around the world. The skyline was no longer an American phenomenon. It had become a global language, a symbol of growth, modernity, ambition, economic power, and hidden inside nearly every tower was the same essential technology, the elevator. Different manufacturers, different designs, different cultures, the same purpose. Moving humanity upward. Act 59. The transportation system inside the building. Most people think of transportation as something that occurs between places, roads, railways, airports, harbors. The elevator introduced another concept: transportation within a place, movement through a structure, movement through a vertical environment. As buildings grew larger and taller, this concept became increasingly important. The elevator was not merely serving architecture. It was enabling an entirely new form of architecture. The tower, the megatower, the vertical city, and humanity's upward journey was far from complete. Act 60. The tallest building on Earth. For more than a century, the race upward continued. Each generation built higher than the last. Each generation challenged assumptions. Each generation expanded the limits of engineering. Then, in 2010, a new record holder emerged. The Burj Khalifa, rising more than 20,700 feet above Dubai, a structure so tall that it seemed to belong to science fiction. A tower visible from extraordinary distances. A building that redefined what architecture could achieve. Yet beneath the headlines and record-breaking height stood a familiar reality. People still needed to reach the upper floors. Gravity still existed. Vertical transportation still mattered. The tallest building in the world depended upon elevators, just as the earliest skyscrapers had. Only now the scale was vastly greater. Act 61. The challenge of extreme height. As buildings approach extraordinary heights, new problems emerge. Wind becomes more significant. Structural movement becomes more noticeable. Pressure changes become more apparent. Travel distances increase dramatically. An elevator ride can become a journey. Engineers must consider comfort, efficiency, safety, performance. Every detail matters. The challenge is not merely lifting passengers. The challenge is creating a seamless experience. A ride that feels natural despite crossing hundreds of stories. The higher humanity builds, the more important elevator engineering becomes. Act 62. The luxury of altitude. Throughout most of history, height was inconvenient. The higher the floor, the more stairs, the more effort, the less desirable the space. The elevator reversed that logic completely. Today, the highest floors often command the highest prices. Luxury penthouses, exclusive residences, private observation levels, prestigious offices. Altitude became an asset, a symbol of status, a source of value. The elevator transformed height from a burden into a luxury, one of the most dramatic reversals in real estate history. Act 63. The megacity. The 21st century became an urban century. More people than ever before began living in cities. Many metropolitan regions expanded into megacities. Populations measured not in thousands, not in millions, but in tens of millions. Housing those populations required creativity. Land remained limited. Demand continued growing. Vertical development offered solutions. Apartment towers, office towers, mixed-use towers, entire districts defined by height. The elevator became one of the essential technologies supporting urban density. Without it, many modern cities would function very differently. Act 64. The world above the street. Walk through a modern city and most activity appears concentrated at street level. Cars, pedestrians, shops, traffic. Yet another city often exists above. Offices dozens of stories high. Apartments hundreds of feet above the ground. Hotels occupying upper levels. Restaurants overlooking skylines. Thousands of people living and working in the air. The elevator made this second city possible. A city suspended above another city. A vertical world connected by shafts and cables, rather than roads and sidewalks. Act 65, the most overlooked form of transportation. When people discuss transportation, they usually think horizontally. Cars, trains, airplanes, ships, subways. The elevator rarely enters the conversation, Yet billions of elevator trips occur every year. In many large buildings, elevators transport more people daily than some transit systems. The difference is perception. The journey is short, the distance is vertical, the technology is hidden, but transportation remains transportation, and elevators have become among the most frequently used transportation systems in human history. Act 66. Moving a city upward. Consider a major office tower at the start of the workday. Thousands of employees arrive within a narrow window of time. Each must reach a destination. Quickly, efficiently, reliably. The challenge resembles managing a busy transportation network. Elevators operate continuously. Passengers enter and exit. Traffic rises and falls. Patterns emerge. Systems adapt. The building becomes a living organism, and elevators serve as its circulatory system, moving people where they need to be. Act 67. The hidden engine of productivity. Modern economies depend upon concentration. Businesses cluster together. Professionals work side by side. Organizations occupy shared spaces. The skyscraper enables this concentration. The elevator enables the skyscraper. Without vertical transportation, many companies would require larger footprints. Longer commutes, more land, different urban designs. The economic efficiency created by elevators is difficult to measure, yet it is enormous. Entire industries operate differently because vertical transportation exists. Act 68. The view of the future. Architects continue imagining taller buildings, more ambitious structures, entire vertical communities, mixed-use megatowers, buildings that combine offices, residences, hotels, retail, entertainment, all within a single structure. These visions depend upon many technologies, but among the most important remains the elevator, because every additional floor creates a transportation challenge, and every transportation challenge requires a solution. The future of architecture and the future of elevators remain closely linked. Act 69. Beyond the skyscraper, the influence of elevators extends beyond iconic towers. They serve hospitals, universities, government buildings, airports, hotels, apartment complexes, factories, warehouses. Nearly every major structure relies upon vertical transportation. The elevator has become a universal technology, one that quietly supports daily life across countless environments. Its impact reaches far beyond the skyline, though the skyline remains its most visible achievement. Act 70. The machine inside the tower. Visitors admire architecture. Photographers capture skylines. Tourists marvel at height. Yet hidden inside every great tower is a machine performing the same task Elisha Otis envisioned generations ago, moving people safely, reliably, efficiently. The technology has evolved dramatically. The mission has not. The elevator remains one of humanity's most successful solutions to one of humanity's oldest challenges. How do you overcome gravity? One floor at a time. Act 71. The Trust Machine. Every day, billions of people step into elevators without hesitation. They enter, press a button, wait a few seconds, and arrive at their destination. Few pause to consider the remarkable act of trust involved. Passengers willingly step into a small moving room suspended within a shaft. They place their confidence in cables, motors, brakes, computers. engineers, maintenance crews, manufacturers, and decades of accumulated knowledge. This trust was not automatic, it had to be earned. And it was earned through one of the most important qualities any technology can possess: reliability. Act 72. The lesson of Otis. The foundation of elevator safety can be traced back to a single dramatic moment. The day Elisha Otis stood before a crowd and ordered a supporting rope cut. His platform did not crash. His safety brake worked. The demonstration changed public perception, but it also established a principle. Elevators must not merely function. They must remain safe when things go wrong. This philosophy guided generations of engineers. Every system required backups. Every failure required protection. Every risk required mitigation. Safety became part of the elevator's identity, and that commitment helped make the modern Skyline possible. Act 73. Engineering against failure. Modern elevators contain multiple layers of protection: braking systems, emergency controls, overspeed governors, communication systems, sensors, automatic monitoring. Most passengers never see these features. That is precisely the point. Safety is most successful when it operates quietly, consistently, dependably. Thousands of engineers spent generations identifying potential failures and designing solutions. The result is one of the safest forms of transportation ever created, not because accidents never occur, but because preventing them became a central priority. Act 74. When the lights go out. Modern cities depend upon electricity. Elevators are no exception. Power failures create unique challenges. Passengers may become temporarily trapped. Buildings may lose vertical mobility. Emergency systems become critical. Backup power, emergency lighting, communication equipment, rescue procedures all play important roles. The goal is not simply keeping elevators running. The goal is ensuring passenger safety under difficult circumstances. Every outage provides lessons. Every lesson strengthens future systems. Act 75. The elevator and accessibility. Perhaps one of the elevator's greatest achievements receives less attention than skyscrapers. Accessibility. For centuries, stairs limited movement. For many people, those limitations were severe. Older adults, individuals with disabilities, people recovering from injuries, parents pushing strollers, workers transporting equipment. The elevator transformed access. Buildings that once presented barriers became navigable. Opportunities expanded. Participation increased. The elevator helped make modern society more accessible, more inclusive, more connected. Its importance extends far beyond convenience. Act 76. An aging world. As populations age across much of the world, accessibility becomes increasingly important. Millions of people wish to remain active, independent, connected to their communities. Elevators play a critical role. Apartment buildings, medical facilities, transportation hubs, public institutions, all depend upon vertical access. A building may be architecturally impressive, but if people cannot move through it, its usefulness becomes limited. The elevator helps ensure that height does not become exclusion. Act 77. The hospital lifeline. In hospitals, elevators perform functions far beyond transportation. Patients move between departments. Medical teams respond to emergencies. Equipment travels continuously. Supplies must arrive where needed. Time matters. Minutes matter. Sometimes seconds matter. A hospital elevator can become part of a life-saving chain of events. Its operation must be dependable. Its availability must be consistent. Its design must account for unique demands. The elevator's role in healthcare illustrates a broader truth. Some technologies quietly support human well-being in ways rarely recognized. Act 78. The Emergency Response Challenge. Firefighters, rescue personnel, emergency teams all interact with elevators in unique ways. Special operating modes, dedicated controls, safety procedures. Building systems must account for extraordinary circumstances. Engineers learned many of these lessons through experience, through testing, through analysis, through continuous improvement. The objective remains clear: protect occupants, support responders, maintain safety whenever possible. Every major building incorporates these considerations into its design. Act 79. The public building. Schools, libraries, museums, government offices, convention centers, airports. These institutions serve broad populations. Their success depends upon accessibility and movement. Elevators help connect spaces, connect people, connect opportunities. A visitor may scarcely notice the elevator after stepping inside. Yet without it, many experiences would become far more difficult. The technology quietly supports civic life, helping public spaces function effectively, helping communities remain connected. Act 80. The social impact of height. Before elevators, the upper floors of buildings often belonged to those willing or able to climb. After elevators, height became available to everyone. A child visiting an observation deck, an elderly resident living in a high-rise apartment, a patient receiving treatment, a worker commuting to an office. The elevator democratized access to vertical space. It changed who could participate in city life. It changed who could enjoy urban opportunities. It changed who could reach the skyline. Act 81. The invisible guarantee. The greatest technologies often become expectations. People expect clean water, reliable electricity, safe transportation. They rarely think about the systems that provide them. Elevators have achieved a similar status. Passengers assume they will work, assume they will be safe, assume they will arrive. That assumption represents an extraordinary accomplishment. A century and a half of engineering success. A century and a half of trust, earned ride after ride, building after building, generation after generation. And yet, the elevator's story is still evolving, because the future may transform vertical transportation as dramatically as Otis transformed it in the 19th century. Act 82. The Smart Building. For most of elevator history, the relationship was simple. A passenger entered, pressed a button, the elevator arrived. The system worked. But as buildings became larger and more complex, engineers began searching for new efficiencies. Thousands of people might move through a tower every hour. Small improvements could produce enormous benefits. The answer increasingly came from information. Computers, sensors, networks, data. The elevator was becoming part of something larger. The smart building, a structure capable of monitoring itself, managing resources, optimizing performance, responding dynamically to changing conditions, and elevators stood at the center of this transformation. Act 83. The end of the button. For generations, elevator passengers selected their destination after entering the cab, a familiar routine. But engineers discovered a more efficient approach. Instead of choosing a floor inside the elevator, passengers could select their destination before boarding. The system would then assign them to a specific elevator. People traveling to similar floors could ride together. Stops could be reduced. Travel times could improve. Waiting could decrease. This approach became known as destination dispatch. It represented a subtle but important shift. The elevator was no longer merely responding to passengers. It was organizing them. Act 84. The age of algorithms. Modern elevator systems process enormous amounts of information. Traffic patterns, time of day, passenger demand, building occupancy, peak travel periods. Computer algorithms analyze these variables continuously, predicting demand, allocating resources, reducing delays. The goal is simple: move as many people as possible, as efficiently as possible. Yet achieving that goal requires remarkable sophistication. The elevator has evolved from a mechanical machine into an intelligent transportation network, one that learns, adapts, and responds. Act 85. The data of movement. Every elevator trip generates information. Patterns emerge: morning arrivals, lunch traffic, evening departures, special events, seasonal changes. Building managers increasingly use this information to improve operations, energy efficiency, maintenance planning, traffic management. The elevator is becoming a source of insight as well as transportation, helping buildings understand themselves, helping cities function more effectively, helping resources be used more intelligently. Act 86. The limit of the rope. Since the earliest passenger elevators, cables have performed most of the lifting. The system proved extraordinarily successful. Reliable, practical, efficient. Yet ropes possess limitations. As buildings grow taller, cables become heavier. At extreme heights, the weight of the cables themselves becomes a significant challenge. Engineers began asking a provocative question: what if elevators did not require ropes at all? What if vertical transportation could be reimagined from the ground up? The answer could redefine the future of architecture. Act 87. The magnetic future. Modern engineers are exploring systems inspired by magnetic propulsion, technologies similar in principle to those used in advanced transportation systems. Instead of relying solely on traditional cables, future elevators may use magnetic forces to move through buildings, upward, downward, potentially even sideways. The implications are extraordinary. Buildings could be designed differently. Movement could become more flexible. Vertical transportation could become multi-directional. Ideas once confined to science fiction have entered engineering laboratories. The future elevator may look very different from its ancestors. Act 88. Beyond up and down. For centuries, buildings have been organized around a simple concept: floors stacked vertically, movement occurring primarily in one direction. Future technologies may challenge that assumption. Imagine systems capable of moving passengers horizontally as well as vertically. Imagine transportation networks operating throughout an entire structure. The distinction between elevator and transit system could begin to blur. Buildings themselves might evolve. New forms of architecture may emerge. Just as elevators once enabled skyscrapers, future elevators may enable structures not yet imagined. Act 89. The Sustainability Challenge. Modern cities face new priorities: energy efficiency, environmental responsibility, resource conservation. Elevators play a role in each. Manufacturers seek ways to reduce energy consumption, improve efficiency, recover power during operation, extend equipment life. Small improvements matter because elevators operate continuously around the world. Collectively, their environmental impact is significant. The future elevator must not only move people effectively, it must do so sustainably. Act 90. Predicting problems. Traditionally, maintenance often occurred after a problem appeared. A component failed. A malfunction occurred. Repairs followed. Modern technology offers another possibility: prediction. Sensors can monitor performance, detect unusual behavior, identify wear before failure occurs. Maintenance teams can intervene proactively, reducing downtime, improving reliability, enhancing safety. The elevator increasingly becomes a machine capable of helping care for itself. Act 91. The Building That Thinks. As artificial intelligence develops, buildings may become more responsive, more adaptive, more efficient. Elevators could play a central role. Systems may anticipate traffic, coordinate movement, adjust operations automatically, respond to emergencies, optimize energy use. The objective remains familiar: move people safely and efficiently. The methods continue evolving. The elevator's future may involve intelligence as much as machinery. Act 92. The Next Frontier. Every generation believes it understands the limits of possibility. Then technology expands those limits. The first passenger elevators seemed extraordinary. The first skyscrapers seemed impossible. The first 100-story towers seemed unimaginable. Yet each became reality. Future generations may view today's buildings the same way, as important steps in a longer journey. A journey still unfolding. A journey upward. Act 93. More than a machine. The elevator began as a solution to a practical problem. How do people move vertically? Over time, it became something larger: an enabler of architecture, an engine of urbanization, a tool of accessibility, a platform for innovation, and perhaps most importantly, a technology that expanded human possibility. The future chapters of its story have not yet been written. But history suggests one thing: humanity will continue building. And as long as humanity continues building upward, elevators will remain part of the journey. Act 94. The Ordinary Miracle. Most inventions reveal their importance through spectacle. The airplane conquers the sky. The locomotive crosses continents. The rocket reaches space. The elevator rarely receives such attention. Its triumph is quieter, more subtle, more intimate. It operates not on distant horizons but within the routines of daily life. People use elevators to go to work, return home, visit friends, attend appointments, stay in hotels, shop in stores, receive medical care, For billions of people, the elevator is not an occasional experience. It is part of everyday existence, an ordinary miracle repeated countless times. Act 95. The vertical home. Consider the modern apartment tower. Hundreds, sometimes thousands, of residents occupy a single structure. Families live dozens of stories above the street. Children grow up in homes suspended high above the city. Groceries arrive. Furniture arrives. Packages arrive. Friends arrive. Life unfolds floor after floor. Without elevators, such living arrangements would be difficult or impossible. The modern residential tower depends entirely upon vertical transportation. The elevator does not merely serve the building. It makes the building itself possible. Act 96. The daily commute. Every morning, a ritual unfolds. Workers leave apartments, enter elevators, descend to the lobby, travel across the city, arrive at office towers, enter another elevator, ascend to their workplace. The process is so familiar that it often goes unnoticed, yet it illustrates a remarkable reality. Modern urban life depends upon vertical movement, almost as much as horizontal movement. For many people, the workday begins and ends inside an elevator. Act 97. The office experience. The office tower is a machine for concentrating talent. Engineers, accountants, designers, managers, researchers. Thousands of professionals may occupy a single building. The elevator allows them to function together. Meetings occur on upper floors. Departments occupy different levels. Visitors move throughout the structure. The elevator connects these spaces into a coherent whole. Without it, the modern office would look very different. Perhaps smaller, perhaps more dispersed, certainly less vertical. Act 98. The hotel journey. Hotels present a unique challenge. Guests arrive from around the world. Many are unfamiliar with the building. Many carry luggage. Many arrive tired from travel. The elevator becomes one of the first experiences inside the property. It transports guests to rooms, restaurants, conference centers, observation decks, amenities. A smooth elevator ride contributes to the overall experience. A poor one can diminish it. In this way, elevators influence hospitality in ways both obvious and subtle. Act 99. The shopping center. Modern shopping centers transformed commerce. Large stores occupy multiple levels. Restaurants operate above retail spaces. Entertainment venues occupy upper floors. Elevators help connect these environments. Families move between levels. Shoppers transport purchases. Workers move supplies. Accessibility is maintained. The elevator allows commercial activity to expand vertically, increasing capacity without increasing land use. Another example of height converted into opportunity. Act 100. The package economy. The rise of e-commerce created new demands. Millions of packages now travel through apartment buildings and office towers. Deliveries arrive continuously. Boxes, food, supplies, consumer goods. The final stages of these journeys often involve elevators. A package may travel thousands of miles by ship, rail, truck, and aircraft. Yet its final movement might occur inside an elevator, a small but essential step in a complex logistical chain. The elevator quietly supports the modern economy, one delivery at a time. Act 101. The building staff. Every large building depends upon people whose work often remains invisible. Maintenance teams, custodians, security personnel, engineers, housekeeping staff, delivery workers. Their responsibilities frequently require moving throughout a structure. Elevators help them perform these tasks efficiently. Entire operational systems depend upon vertical transportation. The elevator supports not only residents and visitors, but also the people who keep buildings functioning. Act 102. The child's experience. For many children, elevators are among the first machines they learn to use independently. Press a button. Watch the doors close. Feel the gentle motion. Arrive somewhere new. The experience can seem magical. A small room that moves. A doorway connecting different worlds. Many childhood memories include elevators, apartment buildings, hotels, department stores, hospitals. The machine becomes woven into personal experience long before its engineering is understood. Act 103. The elderly resident. For older adults, elevators can mean independence, the ability to remain active, to visit neighbors, to access services, to leave home without confronting flights of stairs. As populations age, this role becomes increasingly important. The elevator extends access, extends participation, extends opportunity. It allows many people to continue engaging with community life long after stairs become challenging. Act 104. The moment between floors. Elevators create unusual social spaces, brief encounters between strangers, short conversations, moments of silence. A few seconds shared by people traveling toward different destinations. The experience is nearly universal. People from different backgrounds, different professions, different cultures, standing together in a moving room, then parting ways. It is a small aspect of urban life, yet one familiar to millions. Act 105. The rhythm of the city. Cities operate according to patterns, morning rushes, lunch periods, evening departures. Elevators help create these rhythms, responding continuously to human movement, carrying workers, residents, visitors, students, patients, tourists. The machine adapts to the pulse of the city, becoming part of its daily heartbeat, a hidden system supporting visible life. Act 106. The machine everyone uses. Few inventions achieve such broad reach. Children use elevators. Executives use elevators. Patients use elevators. Tourists use elevators. Residents use elevators. Workers use elevators. Rich and poor, young and old. Almost everyone encounters this technology, and most encounter it frequently. The elevator is one of humanity's most widely shared experiences, a machine so successful that it has become nearly invisible, yet its impact remains everywhere. In every tower, every skyline, every vertical community. Act 107. The invisible giant. History tends to celebrate dramatic inventions. The steam engine, the locomotive, the automobile, the airplane, the computer, the internet. These technologies transformed civilization in obvious ways. Their impact is easy to see, easy to understand, easy to remember. The elevator is different. Its influence often hides behind the buildings it enables. People admire the skyscraper, rarely the elevator. They photograph skylines, not elevator shafts. They celebrate architecture, not vertical transportation. Yet remove the elevator from modern civilization, and entire cities would change beyond recognition. The machine became so successful that it disappeared into the background, an invisible giant shaping the world. Act 108. The Conquest of Distance. Many great inventions conquered horizontal distance. Railroads connected cities. Automobiles connected communities. Aircraft connected continents. The elevator conquered another kind of distance. Vertical distance. A challenge as old as architecture itself. Every floor above ground created a problem. Every additional story increased effort. The elevator solved that problem so effectively that height ceased to be a major obstacle. Human civilization gained a new dimension. Not outward, upward. Act 109, the third dimension of the city. For thousands of years, cities expanded primarily across land. Growth meant spreading outward. New streets, new neighborhoods, new districts. The elevator changed the equation. Cities could now grow vertically. A single acre could support dramatically more people, more businesses, more homes, more services. The consequences were profound. The modern city became a three-dimensional environment, an achievement made possible by one deceptively simple machine. Act 110. The Companion of Steel. Steel made skyscrapers possible, but possibility alone is not enough. A 100-story building without elevators would be largely unusable. The skyscraper emerged not from a single invention but from a partnership. Steel provided height. The elevator provided access. Together they transformed architecture. Together they transformed economics. Together they transformed cities. One built the structure, the other made it useful. Neither could have achieved the same impact alone. Act 111. The Economic Multiplier. The elevator created value far beyond its cost. Every additional usable floor increased opportunity. Businesses could cluster together. Workers could collaborate more easily. Land could be used more efficiently. Urban productivity increased. Entire industries benefited. Financial districts emerged. Corporate headquarters expanded. Commercial centers intensified. The elevator became an economic multiplier, generating benefits that extended far beyond the machine itself. Act 112. The Architect of Density. Modern civilization depends heavily upon density. Innovation often emerges when people work near one another. Ideas spread faster. Resources are shared more efficiently. Services become more accessible. The elevator supports this concentration. Without it, many of the world's great urban centers would require vastly larger footprints. Cities would spread farther. Travel times would increase. Infrastructure demands would grow. The elevator helped make density practical, and density helped shape modern civilization. Act 113. The Great Enabler. Many inventions create new possibilities. The elevator belongs to a special category. It enables other achievements. It allows architects to dream bigger, developers to build higher, cities to accommodate growth, institutions to expand, communities to thrive. Its contribution often appears indirect, yet indirect influence can be enormous. Some technologies change the world by acting. Others change the world by enabling action. The elevator excels at the second. Act 114. A Global Language. Today, elevators operate across nearly every continent, in office towers, hospitals, hotels, universities, factories, residential buildings, airports, government centers. Different nations may speak different languages, follow different traditions, build in different styles. Yet the elevator serves a remarkably consistent purpose everywhere. Move people safely, move them efficiently, move them reliably. The technology became a shared feature of global civilization, a common solution to a universal challenge. Act 115, the paradox of success. The most successful technologies often become invisible. Few people spend time thinking about plumbing, electrical grids, water systems, or elevators. Success removes novelty. Dependability reduces attention. People notice absence more than presence. The elevator's greatest achievement may be precisely this. It became expected, ordinary, routine. An extraordinary technology transformed into a simple assumption. A machine people trust without thinking. Act 116. The shape of the modern world. Imagine modern civilization without elevators. No forests of skyscrapers. No towering residential complexes. No giant hotels reaching into the sky. No vertical financial districts. No observation decks overlooking vast urban landscapes. Many of the world's most recognizable skylines would vanish. The shape of cities would change. The organization of economies would change. The daily lives of billions would change. Few inventions can make such a claim. The elevator can. Act 117. A place beside the greats. History often ranks inventions according to visibility. Yet influence matters more than fame. The elevator deserves a place among the great technologies of the modern age. Not because it is glamorous, not because it captures headlines, but because it transformed how humanity inhabits space. It expanded the practical limits of architecture, redefined urban growth, supported economic development, improved accessibility, and changed daily life on a planetary scale. Its contribution is measured not in attention received, but in civilization built. Act 118. The machine that built the skyline. When people look at a modern skyline, they often see towers, steel, glass, concrete, architecture, engineering, ambition. All of those elements matter. But hidden inside every great skyline is another story. A story of vertical transportation. A story of trust. A story of innovation. A story that began with humanity's desire to rise higher than ever before, and the machine that made that ascent possible. The elevator. Act 119. The long ascent. Thousands of years ago, humanity faced a simple problem. How do you lift something upward? The challenge appeared everywhere, at construction sites, in mines, on farms, at docks, in workshops. Generation after generation searched for answers. Ropes, pulleys, counterweights, winches, cranes. Each innovation made lifting easier. Yet for most of history, one obstacle remained: people themselves. Moving goods upward was difficult. Moving people upward safely was even harder. For centuries, height remained an inconvenience, a limitation, a barrier imposed by gravity. Then, gradually, that barrier began to weaken. Act 120. The moment everything changed. History often turns on moments that appear small at the time. A demonstration, an experiment, a decision, a breakthrough. In 1854, Elisha Otis stood before a crowd and trusted his invention. A platform suspended high above the floor, a rope deliberately cut, a machine that did not fall. The audience witnessed more than a clever mechanism. They witnessed the birth of confidence. Confidence made elevators possible. Confidence made passengers willing to ride. Confidence made developers willing to build. Confidence made cities willing to grow upward. Without trust, the elevator remains a curiosity. With trust, it becomes a revolution. Act 121. The Alliance with Steel. No invention changes the world alone. The elevator found its partner in steel. One solved the challenge of height. The other solved the challenge of structure. Together they unlocked possibilities that neither could achieve independently. The result was the skyscraper, not merely a building, a new form of civilization, a new way of organizing human activity, a new relationship between people and space. The Skyline became possible because two inventions arrived at precisely the right moment. Act 122. The city reimagined. Before elevators, cities spread outward. After elevators, cities could rise. The difference was profound. A single block could support thousands of workers, thousands of residents, entire communities, entire economies. The shape of urban life changed. The meaning of location changed. The value of height changed. Cities gained a third dimension. Human civilization expanded vertically. Act 123. The world above. For most of history, only a few people experienced great heights. The top of a church tower, the summit of a hill, the upper reaches of a fortress. Today, millions experience altitude every day. They live above the streets, work above the streets, eat above the streets, sleep above the streets, observe entire cities from above. The elevator democratized elevation. It transformed height from rarity into routine. An extraordinary achievement hidden within ordinary experience. Act 124. The Quiet Revolution. Many revolutions announce themselves. The elevator did not. It arrived quietly, floor by floor, building by building, city by city, yet its effects reached everywhere. Architecture changed, business changed, housing changed, healthcare changed, accessibility changed, urban planning changed, the daily lives of billions changed. The elevator never demanded attention. It simply transformed the world while people were busy using it. Act 125. The Great Connector. Every elevator journey links places. A lobby to an office, a hotel entrance to a guest room, an apartment to a city street, a hospital floor to an operating room, a visitor to an observation deck. The machine connects spaces that would otherwise remain separated by effort and distance. In doing so, it connects people, opportunities, experiences, communities. The elevator is more than transportation. It is connection. Act 126. The Machine of Possibility. The true importance of an invention is often measured by what becomes possible because of it. The elevator's greatest achievement is not movement. It is possibility. Possibility for taller buildings, possibility for denser cities, possibility for accessibility, possibility for new forms of architecture, possibility for millions of lives lived differently than they otherwise would have been. The elevator expanded the boundaries of what human beings could create. Act 127. The future still rising. The story is not over. Engineers continue experimenting. Architects continue imagining. Cities continue growing. New technologies continue emerging. Buildings may rise higher. Transportation systems may become smarter. Vertical movement may evolve in ways difficult to predict. Yet the underlying challenge remains unchanged. Humanity continues reaching upward, and every upward journey requires a means of ascent. The future will build upon foundations established long ago. Foundations laid by inventors who refused to accept the limits of gravity. Act 128. The view from the skyline. Stand before the skyline of any great city. New York, Chicago, Shanghai, Dubai, Hong Kong, Singapore, countless others. Look at the towers, the glass, the steel, the lights, the ambition. Then consider the hidden systems inside. Thousands of elevators moving continuously, day and night, year after year, carrying workers, residents, visitors, dreamers. The skyline is not merely an achievement of architecture. It is an achievement of movement, an achievement of access, an achievement of transportation. Act 129. The underappreciated invention. Some inventions become legends. Others become assumptions. The elevator belongs to the second category. Its success made it ordinary. Its reliability made it invisible. Its impact became so complete that many people stopped noticing it altogether. Yet history tells a different story. Without elevators, the modern city would look fundamentally different. Without elevators, many buildings would never exist. Without elevators, countless opportunities would remain out of reach. Quite literally. Act 130. The invention that built the skyline. From ancient lifting devices to intelligent transportation systems. From simple platforms to high-speed elevators, serving the tallest buildings on Earth. From a world limited by stairs to a civilization organized around height. The elevator reshaped humanity's relationship with space. It helped create the modern city. It supported the growth of economies. It expanded accessibility. It enabled architecture once thought impossible. And it did all this while remaining largely unnoticed. The elevator did more than move people. It changed where people could live, where they could work, how cities could grow, and how civilization could imagine its future. It is one of the most important inventions ever created, one of the most trusted machines ever built, and one of the clearest examples of how a single idea can transform the world. The skyline rises above us as a monument to that achievement. A forest of towers, a symbol of human ambition, and hidden within every tower is the same enduring story. The story of the elevator, the invention that built the skyline.